Let's take a quick tour of some of the new capabilities in Automation1 2.11. So you'll see here, this is the splash screen of Automation1 Studio. I'm going to log into this local controller called Galvo Scanner System. So I'll select that and I will connect. You'll see when you first upgrade or install Automation 2.11 from an old version, you'll have a pop-up box that says what's new in Automation 1. This will give you some overview of some of the new products. So for example, you'll see this image here of our new AGV10 CPO product, comments about some of the new drives, the new capabilities, and then also some enhancements and features that have been added to Automation 1 Studio. Now, of course, this is only going to show up the first time that you open up the new version. After that, it does not show up anymore. You can either close directly out, or you can go to the Start screen to learn more. So let's click Go to Start Screen. And you'll see the Start screen here. Now, we've updated this based on user feedback to have multiple different things. First here is we see what's new, we see what version we're in, and then if you click here, you can see the release notes. So this will contain all the release notes from Automation 1 through the different versions. The release notes are now embedded directly into the MDK. Again, let's say that you have logged into this and you didn't go to the Start screen. Let's say you're in Develop maybe. When you go to Develop, you can go to the Start screen just up here next to Develop, Configure, and Start screen. So you'll also see these tiles. These are containing some of these new products, new capabilities, and new features. They also have links that this will take you directly to the web page for the AGV CPO, to the web page for this product. This will take you to the help page or help file. These will take you to the different modules. So for example, for variables and IO favorites, we can click Go to Module, and you'll see this variables IO module over here. I currently have nothing selected as a favorite, but I can go into here and I can select, maybe I want the analog input channel 0 to 2 and digital input bit 0. Now these things are in my favorites, and if I'd like, I can go to Manage. I can name this and now I can add it. So you'll see these now here as a favorite group. I can add other favorite groups, and this is going to stay persistent. So if I change Automation 1 versions, log in, log out, log into a different controller, I'm still able to access this without having to change it. It makes programming much easier. Now if we go back to the Start screen, so obviously we discussed those release notes up here. We discussed these tiles. You can continue to scroll and you can see other information on these tiles, right? Gantry Easy Tune, Calibration module, things like this. Now another thing you'll notice is we now have a recommendations section. This section is going to be used to recommend things to improve performance, to improve throughput, to improve precision, to improve controller performance, things like this. So you'll notice here, this particular system, it's not connected to any hardware, so you'll see this eye icon at the bottom. That's just because it's not connected, it's in virtual mode. I have an X, a Y, and a Z axis, and I have two Galvo scanner axes, GX and GY. So this will tell me here, hey, just so you know, user, your motion update rate value could be improved. It's telling me that I can set it up to 100 kilohertz. Instead of taking a 1 kilohertz signal and interpolating it, it'll actually generate the trajectory mathematically at 100 kilohertz. This will improve my performance, especially for things like doing tight corners, small features, small circles, things like this. So you'll see things pop up here on a regular basis, and as we move forward with new versions of Automation 1, you'll get continual recommendations and updates on how to optimize your system. And you'll see here, if I want to, I can click on Go to Module. It'll take me right to that parameter, motion update rate. You'll see that here. If I don't know what that parameter means, I can come over to the sidebar and select the question mark, select the parameter, and it will show me a description from the help file of what this parameter does and what it means. So you'll see here, I have some axes that can do a 10 kilohertz rate, some that can do a 20 kilohertz rate, and others that can do a 100 kilohertz rate. And I can do 100 kilohertz because I have Galvo axes, so I'm going to set this to 100 kilohertz. And you'll see over here I need to save the changes. So I'm going to save and apply. So that's one example of some of the new capability here in Automation 1 in order to help improve performance. Something else that's been added is our Galvo calibration capability. So if I click over here on the Calibration tab in the Configure Workspace, you'll see I currently have no calibration files configured. I can add calibration files from a calibration file, or I can make an empty table. So if I go from a file, you'll see here I can load my calibration file, and it displays an Excel style table where I can go in and I can edit each of these values, each of these correction values at a GY and GX location in my scanner field of view. You also see on the bottom that if I expand this, it shows a nice visualization. It shows an indication of the cell that I'm on, so I can click here. You can see it moving through the cells. And you'll also notice that if I zoom in, we have some vector directions and vector magnitudes shown here, both in the heat map style and in the length of the actual vector on the plot. So this helps you when you're trying to do a mark and measure correction, where you might be marking a part and you're trying to see how much error is there on your part versus what you expect using some sort of microscope or measurement device. Then you can open up this table and configure your error. Now if I don't save this, I'm not going to save it. The other option is I can do this from an empty table. So if I click do from the empty table, I select Galvo axes. And by the way, this will not show up for other axes. You'll see there's only two Galvo axis pairs here. One Galvo axis pair here with two axes in it. It will not show up for servo axes. The amplifier that it's designed for, field of view type, etc. So I might want to do a 9 by 9 table, and you'll see it gives me what the sample distances are in millimeters because my field of view size is 107. I can also select the orientation of the scanner versus the field of view here. Here's what we get. And it generates, again, one of these plots. Now you'll see here, this is a little smaller, so it's a little easier to see. I have no correction values. If I want to select the center of the field of view, maybe that's where I'm starting my measurement, I can put in my correction value. And I may have to zoom in here because it's fairly small, but you'll see the vector magnitude and direction of that correction. So another new capability that was added in Automation 1 2.11 is the restrict motion feature. Let's start by going to the develop workspace, and we're going to expand the access dashboard at the bottom. You'll see that I am able to enable home and jog axes down here on this access dashboard. Obviously I can do this programmatically as well. I'm going to start a new program, and this new program we're going to just save as motion restriction demo. Okay, so this is a new AeroScript program, and we're going to just show some of these motion restriction functions. If I use the autocomplete here to select motion restriction on, you'll see that there's a couple ways to do this. One is to use the default value, which is to add the axes in here, and it restricts the home and enable features and the motion features on the axis. The other is to do a custom type where you can select what things you'd like to restrict. So this is an overload for that function. Let's start with the default case, and then we can show the custom case. So I want to restrict the X and Y axes. I'm going to save this. I'm going to build it. So when I run this program, what it's going to do is it's going to set these axes into a restricted state where I'm no longer able to move X and Y. For completion's sake, I'm going to enclose this in a program block. going to build again, and you'll see I'll run this. After the program runs and is completed, you'll see that the X and Y axes move into this restricted state. So now I am unable to home. You'll see I get an error. It says I cannot home because it's restricted. I am no longer able to jog. I'm stuck at minus 1.7 millimeters on the x-axis and 1.9 millimeters on the y-axis. You'll also notice I can jog the z-axis. Additionally, I'm able to disable the axes by default, but I cannot re-enable. So we're going to edit this program. First, we need to turn off the existing motion restriction. To do that, we're going to use the motion restriction off function, and we're going to turn these off for the X and Y axes. After we do this, we're going to edit the motion restriction on function. And we're going to use this overload. This allows us to select the specific types. So let's do this on the x-axis. We're going to restrict motion on the x-axis, and we're going to use the motion restriction type enum. So I select the enum, and you'll see here the options. What are the things we would like to restrict? Maybe we're okay with enabling, we just don't want someone to be able to disable. So if that's the case, I'll do this. I will build the program, and I'll run it. Now you'll notice the axes are still in the same state they were before. I am able to enable X and enable Y. I'm able to jog X. Again, the only thing we're restricting here is disable. But watch, I am no longer able to disable X because I've restricted that. Y I'm able to disable because it's no longer in this program. So it's a very flexible capability that allows you to control exactly when your operator can and cannot do things such as enabling, homing, commanding motion, aborting, or disabling axes. And you're able to do this on an axis by axis basis. The other thing that is included here is if you'd like to restrict this at an operator level, but you'd also like to be able to do things with the x-axis in the program, you can use these motion restriction allow commands. So this will set it up so that you can do something with that axis on this program. So maybe what we want to do is disable the x-axis, wait 1 second, and then enable the x-axis in the program. And we don't want the operator to be able to interfere with this. So we'll complete this program by ending the restriction section. Now again, you see here on the left-hand side, the yellow indicates that this is not saved or built. So I'm going to save it. Now you see it's all saved. I'm going to build it. I am going to run this program. So you'll see it's disabled X and then it re-enables 1 second later with the motion restriction. I still cannot disable, however, I can jog. So it's a very flexible capability that allows you to control every aspect of your process. Let's move on to the visualizer and changes that have been made here. So if we move to the visualize workspace, we can open some existing step and settle data. So here you're going to see a step and settle 1D plot. This was taken on an axis. It's a 3mm move, and maybe we care about the position error, and we want to know when does the position error go below a certain threshold. We might start by zooming in on the plot to see the position error, and maybe we don't care about the acceleration or current command. So we can edit this plot. We can hide everything except for the position feedback and position error. Now the thing that's been added in Automation1 2.11 is this cursor annotation capability. So you'll see here what I need to do is I need to select the signal that I care about. It's the position error signal. And you'll see the position error signal. Maybe I would like to add one of these annotations. And I'm going to select inside. So when the error band is inside my range might be, let's put it at 100 nanometers. So that's microns. The minimum is negative 100 nanometers, and the maximum might be 100 nanometers. I can select a color if I want a custom color, so maybe I want this to be orange. And you'll see it puts an indicator at the 100 nanometer mark. Now, a lot of times we have users who care about two different values. One is an initial settle value because I know I can start to trigger my inspection equipment, for example, at 100 nanometers. But maybe I also need to know when I achieve a smaller range, like 10 nanometers. There's microns, there's 10 nanometers. And for this one, let's use a purple color. So you'll see these here. And when I select update, you can see exactly when it reaches each value. So what's interesting about this is in this particular case, during the move, I actually stop exceeding 100 nanometers of position error in the middle of the move. So I can start to trigger my device here, and my 10 nanometer position error is no longer exceeded here. So these new cursor annotations just make it easier to visualize and measure the performance of your system when you're programming it, debugging, and commissioning. Thank you for taking the time to check out some of the new capabilities in Automation1 Studio, and feel free to reach out if you have any questions, concerns, or other problems that you'd like us to help you solve.